Hello coders, welcome back to my video. So we'll continue the Makefile session that we left in the last video. So if you haven't seen the last video of Makefile, just go and see that video first before proceeding here. So we were at the location where we create a generic Makefile. So in this video, what we're going to do, so if we have multiple files, a lot of files, so we need a lot of rules like this. Okay, so that is very tedious and time consuming. So we don't want that. So Makefile give you an approach of using the automatic variables and some wildcard variables that helps in doing this operation in very less time. We have two things in the Makefile. First is a variable, like we define here target is equal to smart home. Okay. So for example, in here we are using GCC. If we need some other, compiler, so we have to change every line where GCC is written. So for that, what I will do, I'll take a variable CC and I'll give GCC here, and I will replace every GCC with CC. Okay. So maybe this will solve the purpose. Okay. And I try to remove these all things. Okay. So now I need .o files. Okay. So I need all these .o files that will create this target smart home. Okay. I will take %.o as target and %.c is a prerequisite. Okay. And then what I will do, I will take GCC here, then -c. Now I need what the all the .c files. Okay. So what I will do, I'll take dollar and this, that's an operator here. So here we have the prerequisite. So this is a automatic variables that will take all the prerequisite here, and we have a wildcard percentage here. So it will take all the .c file that is present within the folder. Okay. So then I take -o, and then we have our target like this. So here we have multiple targets because we have a wildcard here. So for each .c file, we will create one .o file. So if I do like this, I will get all .o files, build it first. Okay, and let's see if this works or not. So here dollar at the rate will define this target, and dollar less than defines the prerequisite. Okay, let's save it, and I will take make again. Okay, you get all the files. See here. So in spite of taking each and every rule for each .c files, this will help us. Okay, so this is one. Then we will change this rule as well. Make it short. So for that, what I will do, I'll take from here, copy it. Then I take here objects. So these are the objects. Okay, so objects variable I will take, and equal to, I'll insert all these. And here, what I will do, I'll take this variable. So dollar objs. Okay. So now I'll try to change this rule as well. So in spite of GCC, I will take CC. Okay. Then I need to link all the dot objects files here, right? So for that, I'll change it again. So that, okay, so I need the target. So the target is defined by this. So if we do like this, so here we have only a single target. So this will take only the single target for dot O, and then dollar, we need objects. Okay. So now this object should be there. Okay. So now it's become very simple. Okay. So it will combine each and every object and make it the target. That is smart home. Okay. So now what I will do, I'll save it. I'll make clean first and then make again. Okay. So now everything is done. So until we make clean, it won't give us make. So if you see here, this four is for percentage dot o colon percentage dot c rule, and this last one we get from the latest rule that we have changed. All the dot o converted into smart home, and if I do ls, I get a smart home, and it will run as well. Okay. So if I do make again, what will I see? Nothing to be done. All is up to date. Okay. So if we do -lrt, you'll see the time of each file where .o is created. So for example, I did some change in sensor.c. Okay. For now, what I will do, I'll just touch this file so that the timestamp got changed. So if I do ls7 lrt again, has been changed now for sensor.c. Now, if we do make again, there is an optimization done by the make. So what it will do, it will only compile the sensor.c, that timestamp got changed. So from timestamp, the compiler will get to know, okay, yeah, something has been changed from sensor.c. So I need to compile it again. Okay. So this is some optimization that is being done. So the similarly we can do for all the files. Okay. So one thing here to note is if I touch now sensor.h, okay, and now if I try to do make, it will show nothing to be done for all. So though we have changed uh .h file. So what to do for this? So if I check our make file for this rule in which .o is dependent on only .c. So all .c are the prerequisite, nothing for .h. So if I make this rule a bit change, and I'll do .h as well. So these are the two pre-requirement for this target for each file. So now if we change sensor.h, it will compile sensor.c and it will modify sensor.o. So let's see. So I changed it. Now what I will do, I'll just do make. You will see your sensor.h c got compiled again. Okay, let's try it again. Nothing to be done. Okay, I'll touch this sensor.h file, and when I do make, it will compile again the sensor.c. So this way we can set our prerequisites for our target to make this optimization in our Makefile. So these are all the advantages. And if one more thing left in here was the phony tags. So what if we have clean, run, and all targets here? Okay. So what if we have some files naming convention like this? We have some file name clean. So make often get confused between the make file target and that particular file in the folder. Okay. So for that, what I have to do, I will take phony. So this is a target tag, and I'll mention all, clean, and run in that. Okay, so it will ignore the file name named by this in the current directory, and it will make will understand, okay, we have these targets and we have to run through this target. So this is how our make file works. Thanks for watching.